Okay guys, welcome once again. This is the young modulus solution. As always, I'm always there to make sure that students go into the exam hall and write the exam successfully. And of course, one of the key things that you need to do is you have to prepare, get the proper materials that you need to get, and then also know your scheme of work, what has been covered for the semester, and then work on them accordingly. All right, so this is Precalculus, okay, and basically in this series, in this month of July, okay, I'm basically trying to see how I can help our students in the University of Port Harcourt, all our subscribers in the University of Port Harcourt. And of course, if you are in other university, of course, maybe you're not writing exam this period, you're writing exam this period, just represent your department or your school in the comment section. Both those in University of Port Harcourt, I want to just know you, because I may not know you by your email, okay, yes, by your email address, but I may know you through your comments in the section. So if you are University of Port Harcourt students and you are watching this video, of course you are in the right place, okay. Just comment the University of Port Harcourt, possibly the department if possible. Then if you're another university within the country or outside the country, you can also comment there, and I will also make sure that I also touch anything relating to your course, your exams, okay. However, the topics we are handling here is a precalculus, things you need to know, some basic tools I feel we should know before we delve into topics like limit and continuity, domain and range of functions, and of course differentiation and integration. There are some basic tools that we need to know that will really help us in the course of this topic, okay. And as we also go in through, we also look at other formulas that are related to that very concept, okay. So do well to comment and let me know if you have any question, or you are writing your exams, or you're having challenges. Drop question. I want to be getting questions, okay. Getting questions. My WhatsApp number is there. Drop question in the comment section. I want the comment section to be booming, okay. Just do that for me and I'll always be there to respond. Of course, turn the notification bell, because I'll be dropping about 5 videos on calculus, okay. The first one here is precalculus, and of course I will also continue with other topic, okay, as we move on. Okay, so you can see there what we have here. Permit me to use this textbook. It's a very special textbook, which I feel that if you have this textbook, it's really going to help you, okay. It's an additional textbook that you may need in your this in Collins college outline, introduction to calculus. So the first thing we have there is our what we call precalculus, which I call introductory topic, okay. Now the first thing that we need to know here is our real number line. The real number line, of course, is the normal thing we've been doing at secondary school. So you have it here, and then we have the center 0, and then anything to the left of the 0 is a negative number, and anything to the right is a positive number. And of course you can think about any number on this real number line, both a natural number, both a rational number, both how do they call it, integers, and the rest of them, okay. You can see them there represented. So you need to know this real number system, because it's going to help you when you're talking about domain and range, okay. Now another aspect again that will help you at domain and range is, of course, how to represent intervals. So first of all, you need to know, of course, our less than sign, our greater than sign, of course, the less than equal to, and the rest of them. You need to know them properly, because that's what you're going to use to denote the solution to your domain and range of any given real value function, okay. So we also have interval notations, of course, and then set notation, using the set notation format. Now if you have actually followed up my videos and other my classes I've done so far for those in University of Port Harcourt, you notice that we've been using this stuff even in algebra and trigonometry, when we are dealing with sets, and also when we are dealing with domain and range of functions, okay. So we see that normal bracket means open interval, and it is given in this notation, in this form, as this, x such that this dot dot means, this column means such that -1 is less than x less than 3, okay. Now in graph form, you can see that in graph form is given in the graph form, and in the graph form they use normal bracket to represent that also, okay. Now what this actually means is that the number that are included in this set, a number before -1, the number after -1, a number before 3. The number after -1, a number that is this -1 and this 3 are not included in the solution. So if you come to your number line, you notice that the number begins from 0 down towards 2. That's what that statement means. The number begins from 0, so from 0 towards 2. That means this extreme number are not included in the solution. So if you also check the next one also, if you watch here, they use square brackets. First of all, they set interval. The interval notation, they use square bracket. Okay, so and here, when you see square bracket, it means that the extreme numbers are included. I didn't know that the extreme number are perfectly included. That's what it means for you to have. Okay, so that's what it means for you to have this. So the extreme numbers are included. And if you also check here, they use square brackets to represent it. The square bracket here, and then here they use less than or equal to. Whenever you see less than or equal to, you automatically see square bracket. And in the graph notation, they also use square to also look at the extreme, to include the extreme number. So this is close interval. It is close on both ends. Okay. Now look at this one. This is half open and half close. Half open and half close. Okay, it's having one of these and having one of these. So it's half open, half close. Where you have normal bracket is half open. Where you have square bracket is a close. Okay, is a open, here is a close. So in the symbol too, in the set notation too, where whenever you see normal bracket is less than we use there, with that equal to. Whenever you see square bracket, you now see less than equal to. If you also look at the graph too, the same thing. So you can go through this again and then watch the video again and see how you can also work on that. So you can see an example given to us here. A graph each set on a number line. Actually, they are not going to ask to graph anything, but you need to know what that actually means when you are graphing that. So in the graph method above, so you can see that here we have open interval, close interval, and then open and close interval. All right. So we have open interval, the first one. Second one we have close interval. Then you have the third one, we have half close and half open and half close. So you can see the graph here accordingly. If you have followed the explanation on that table I gave us earlier, you can see the graph there. Okay. So like I said, you may not actually be asked to graph anything, but it's good for you to understand what is going on here. Then if you look at this also, look at this one. This is close on both ends. You can see the solution. They say because the endpoints are included in the solution, use bracket. You use what? You use a square bracket. And then if you watch it, they've also taken this region to show that these are the region where we are considering. Okay, so you look at the second one. Second one is open interval. In open interval, you use normal bracket. Have you seen the graph here? So in the third one, we have a half closed, half open. This is equal to, less than equal to, half closed, half open. All right. So we have that over there. So you can see it here. So half closed and half open. All right. So and so on and so forth. So you can see that the thing still continue. So in this case again, just like to conclude this section, we also have what we call unbounded intervals. Unbounded intervals are intervals like when we say s greater than or equal to 2. Now in the set notation form, this is it. They say greater than or equal to 2. Because of this equal to, that's why, because of this greater than or equal to, that's why we have square bracket. That means the number begins from 2 to infinity. Please, it's good for you to know this because under domain and range, we are going to be discussing in the part 2 of this video. We are going to deal with the families of numbers, okay, set of numbers which you cannot exhaust. So we use this interval to represent them. So at times you see unbounded intervals, especially in the case where we have radical functions. Let's say you are asked to find a domain, a function like f of x equal to, let's say, x minus 2, the square root of x minus 2. And of course, when we go through, you notice that for you to find the domain of such function, you have to set the function to be greater than or equal to 0. Then you now solve. Okay, so you start having numbers like this. So in this case, we have unbounded intervals. Just a single inequality sign is used in that case. So the number can, when we say unbounded, means you cannot close it. It moves to infinity. Okay, like the one we have here, the first one we have here, we said 2. The square bracket here means the 2 is included. Then comma, the infinity sign goes in, and then this. Now, during one of our classes in the algebra and trigonometry, one of my videos I explained, okay, on the examination tips, I mentioned that you cannot close infinity. yes, we know that the number is from 2 and above to infinity, but you cannot close infinity. That's why we use normal bracket. So we don't use square bracket for infinity. So you will see such questions say which of these is not correct, which of these is invalid. They will give you different intervals. They will give interval of this form. Just know that anyone that contains square bracket by the side of the infinity, it is not correct. So that's why we call it unbounded intervals. So in this case, we have this. So the representation is given as this: x such that x greater than or equal to 2. And of course, this is what it means in the graph format. Then number 2, we have this also. Now this one says x is less than 1. X is less than 1 means that 1 is not included in the answer. So the value of x we're looking at are the values that are less than 1. So if you go to your number line system, you can see that if you go to your number line properly, the result we are looking for in that very problem is number, they say less than 1, number from 0 down. Or any number less than this one, let's say 0.99999 or 0.98 or something, down to what? Negative infinity. That's why you see negative infinity given here in the first place in the interval notation. Are we there now? So this is what we have here now. Okay, the negative infinity, sorry, the negative infinity that is given to us over here. Okay, so in this case here, our number begins from any number from less than 1 down to negative infinity. And of course, this is what it means to represent in the interval in the graph format. Then this one is a combination. This is a combination. So this is open interval combining with union. This is a union with what? Open interval again. So now they said in the set notation, it means x is less than minus 1. X less than minus 1. So anything less than minus 1 down to negative infinity. That's what this thing means. Then this one says x is less than x greater than what? 3. Or x greater than 3. So you can see that here the negative infinity, the infinity here is positive. That's why we use greater than over here. So any of this are what I want you to know, because that's what we'll be using in our domain and range representation, because domain and range contain some families of number. Okay. Alright, so there's an exercise given to us here. Say we should complete the following table, and of course the answer is there, okay, with us. And this is closed interval this side, and this is open interval this side. So this is going to be minus 1 less than or equal to x less than 4. And of course the graph is given like that. Then here we have closed interval 2, and then here we have infinity. So this is an unbounded interval. This is bounded, this is unbounded. Unbounded means that infinity is involved, so you cannot close it. So we have x greater than or equal to minus 1. Then this is also another unbounded interval. Okay. So here, now here they are using I don't think this is not correct. They are using a close interval on the, you see, they are using a close interval on the infinity. We cannot close infinity. Infinity is as big as this end. We can't close it. So this is not correct. I won't accept this is not correct. So I think it's good for us to see such question. This is not correct. So this is supposed to be a normal bracket. It's supposed to be a normal bracket, and not a square bracket. Okay. So that's what we have here. So that's why you see x less than 2. So anything from 2